Welcome to the first video of calculus. In this video, we'll be looking at differential calculus in particular. And in your syllabus, this is in the AISL syllabus, this is topic 5. So let's get straight into it. So before we start, we must know what calculus really is. Well, there are two sections of calculus. There's something called integration and something called differentiation. In this section, we'll be looking at differentiation. So first of all, let me just give you what integration is, just a brief idea. Integration involves finding area under a curve, right? Area under curve, and differentiation will be explored in this video. To explore differentiation, we'll be looking at a scenario. So let me just erase this real quick. So let's start off a basic graph, basic linear line like this. Let's say if someone asks you to find the gradient at a specific point, let's say gradient at this point here, right? Let's say someone asks you to find that. Well, most of you will know that the gradient is just equal to rise over run. And this will work because if you think about it, the gradient here is the same as gradient here because this is a straight line. So it means the gradient is constant. The slope or the steepness of the line is constant throughout the whole entire line. But let's say you have, I'm gonna rub this out. Let's say you have another Cartesian plane which has a parabolic function such as this. Now, if I ask you to find a gradient at a particular point, let's say here, many of you will be confused because in this curve you can see that the steepness, the slope is always changing. So let's say the steepness here is like that, but the steepness here is much more steeper. So in this curve you can see that the gradient is not constant and it's always changing. So gradient at this point would not be the same as the gradient at this point, right? So hence there's something called differentiation. Differentiation aims to find the slope of a particular point in a graph, and this slope is known as the instantaneous gradient. Instantaneous means at that instant, at that specific point, right? So this aims to find the gradient at this specific point right here. So let's explore. Now you know what differentiation is. Let's explore how you use it and the notation of it. So let's say you have a function f of x, and let me call it x squared. So you want to find the gradient of, let's say, x at x equals 5. So at x is equal to 5. So what you would do is you would differentiate this function. Don't worry, we will learn how to do this. So differentiate. Differentiation can also be called finding the derivative. So when I say finding the derivative, it's basically the same thing as saying differentiating this function. Differentiating just means basically doing something to the function to get another function. So when you differentiate this function, you get another function g of x, and you don't know what g of x is right now. We'll learn how to differentiate in the next slide. So when you get this function, you can just simply sub in x equals 5, and then you get the gradient. So it is a pretty simple step. You have initial, let me just get a laser pointer. You have initial equation f of x. You differentiate it, and from the differentiated function, you get another function, g of x, right? And then in g of x, you just sub in the point that you want the gradient at. So I want x equals 5. So you would just sub in x equals 5 into this differentiated function, and then you will get the gradient at that particular point. It is a very cool method, right? So let's now you know how it works. Let's learn how the symbols and the notations of it. So I'm just gonna quickly erase, get the pen. So there are many ways to notate a derivative. So remember, derivative is just when you're differentiating a function, right? They're basically the same thing, but when you're doing the process, everyone calls it differentiation. But when you find the equation g of x, you call it the derivative, right? So let's say I have a function f of x, and I want to differentiate it. So when you differentiate it, you get another function, as I said, right? So how do you notate that? Well, you notate it by saying f dash x. This shows that you've differentiated it. So hence this is what is called the derivative, right? Derivative is basically the process of differentiating, right? So you can represent it as f dash x. Remember, f dash x is not the same as f negative 1 x. This is showing the inverse of a graph. This is showing an inverse of a graph, but this is showing a derivative of a graph, right? So they're basically not the same thing. Now, you can also represent it by dy over dx. So we'll encounter in the questions that are coming up in the next slides on what this means basically. So these things are basically the same thing. What this is saying is you're differentiating in terms of x. This is basically saying the same thing, but just in a different and much more, I guess, easier notation to read, right? So let's learn how do you differentiate a function, and how do you apply that to find a derivative. So first of all, there are many rules in differentiation, and in this video we'll be looking at the power rule. So what is a power rule? So let's say I have a function y is equal to a to the power of x. The power rule states that the derivative of this derivative is just, so here you have a hidden one, you just don't write it, right? A is basically the same as 1a, but people just don't write it. So what happens is you multiply multiply x by the number that is in front of a, which is just 1. So you have x multiplied by 1, which is just x, and then you just leave a as it is, and then you minus 1 from the exponent. This is the law of power. This is called the power rule, right, in differential calculus. So let me give you an example. Let's say I have f of x is equal to x squared, and I want to differentiate it to find the derivative, basically the same thing. So I apply this rule, apply power law, right? Power rule or law, same thing. So what it says, I'll just write it in the terms of y instead of f of x, which is much more easier. So y equals x squared. So now you have y is equal to, there's a hidden 1 in front, people just don't write it because they're lazy. So you write 2, you have 2 times 1, you multiply it by the number in front of x, which is just 1. So 2 times 1 is 2, you have x, and you just minus 1, x minus 1, which is just 1. So you just have to remember that you multiply the exponent by the number in front of in front of x, and then you just take away 1 from the exponent. So this is the derivative. See, as I told you, you get another function. This is just another function. I can represent it by y dash to show that it is differentiated, right? Now, let's say I want to find the gradient at x equals 5. I can just sub it in this equation, 2, 5. so it will be 10. The gradient at when x is equal to 5 of x squared is 10. That's really cool, right? With this method, you can find a gradient of basically any function. You differentiate it. So that's why calculus is so useful. And there are many applications of this which we will explore in the later videos. But now let's get into the questions. So I have the question: f of x is equal to 5 x to the power of 4, then find the derivative. See, f dash x, that shows it's a derivative, right? And let me get my pen. So I'm gonna just write power rule on the side. Oh, my pen just disappeared. So I have power rule saying, I have y is equal to x to the power of n, right? Just n, x, n minus 1. So you have y is equal to 5 to the x to the power of 4, right? So you basically times this number and this number, which is this 20. Quick math. That's 20. X just stays the same, and then you minus 1 from this. So 4 minus 1, which is just 4 minus 1 is just 3, and you have this as your derivative function. Fairly easy, right? So let's go on to the next question. Oh, interesting. Do you notice this notation? D over dx. Remember, dy over dx is the same thing as just f dash x, but in this case it's different. There's no y. Well, why did they do that? Right? Get that pun? Why did they do that? Well, basically you don't have to write dy. You can just write d over dx. Basically, the thing is, you just need to know what you're differentiating with in respect to. So this is differentiating in respect to x, right? So that you're doing something to the x, right? That's what respect to means. So you're finding the derivative with respect to x. So let's just do this question real quick. So I have d. I have a function. I'll just rewrite this. Sorry. Y is equal to 3 x to the power of 2. Now I want to find d over dx or dy over dx. Doesn't matter. It's the same thing. So 3 times 2. Apply the power rule. So power rule states that you times the number in front of x and the exponent. So 3 times 2, which is just 6, and then you take away 1 from the x. 2 minus 1 is just 1. So you found the derivative is 6 x to the power of 1. And you know that x to the power of 1 is just x, right? So the answer is C. Let's go to the next question. Okay, this is an interesting question. Because instead of just having one term, you have multiple terms. You have this and you have this. So what power law states is that when you have multiple terms like that, you find the derivative of this, and then you find the derivative of this, and then you just combine them, right? So first, let's find the derivative of z to the power of 3. So there is a hidden one. People just don't write it. So power law states that you have to multiply this 1 by 3, which is just 3, and then you minus the exponent by 1, which means 3 minus 1, which is just 2. So you found the derivative of this. Now here is where people get caught up or tricked, right? We found the derivative of this part, but now we have to find the derivative of this part here, right? But the derivative doesn't just involve this, it involves the minus sign with it, right? So that's what you must know, that you include a sign that is in front of the number, right? So you find the derivative of that. So negative 3 times 2 is negative 6, and then z 2 minus 1, which is just 1. So that is that. Now you just combine them together. So like join them together. So if I join them together, it'll be 3x squared minus 6z, right? So which option is that? It's definitely not this option. Definitely not this option. It's option D, right? It's pretty simple. Let's get into the next one. Ooh, this is interesting, right? You want to find the derivative of this whole term, right? Well, how would you do that? Well, how about if I just expand the brackets? If I expand the brackets, you get something to the x squared term, right? And then you can just apply the power law to the individual terms. So let's do that. So let me just expand this. So x minus 1, x plus 3. So I'm just gonna use FOIL. So x squared plus 3x minus 1x plus 3. So that is basically x squared plus 2x plus 3. That's the expanded form. Let me just rub this thing out so I have more space to write. So that's the derivative. That's what we want. That's the function, right? So here we look at the individual terms and find their derivative and just combine them. That's what power law states, right? When you're adding or subtracting, obviously. So find the derivative of x squared. So there's a hidden 1. So 2 times 1 is 2, and then you write x as it is, and then you take away 1 from the exponent. That means 2 minus 1, which is just 1, right? And now you look at this section. This section, 2x, right? So let's look at 2x. So there's a 1 on top of x. You just don't write it. So 2 times 1, which is just 2, leave x as it is, and then 1 minus 1 is 0. And you know that x to the power of 0 is just 1. So you can replace that saying 2 times 1, which is just 2. So you found this, and then this. And then you just have to find x to the power of 3. Sorry. My bad, just 3. So find the derivative of 3. Well, you can write 3 with x to the power of 0 because x to the power of 0 is just 1. And if I multiply anything by 1, it's never going to change, right? It's just going to stay the same. So let's say if I have 10 times 1 just stays the same as 10, right? So it's not going to change. And from this, because I manipulated in that way, I can use a power law. So 3 times 0 is 0, and then you minus 1. Well, no, I don't have to go further because anything times 0 is 0. So the derivative of 3 is just 0, right? So combining everything, the derivative will be, I'll write it here, 2x plus 2 plus 0. We don't have to write the 0. And then if you look carefully, it can't be option A, it can't be option B, it can't be option C, it must be option D, because you can see it's the same. Okay, and now we have a challenge question. The challenge question is very interesting, and it's pretty easy if you think about it. So in this we have to find the derivative of 3 to the v to the power of 5 plus 4 times v to the power of 2 minus 5 divided by v squared. It seems like a lot to take in, but it's very simple, and I'll show you how to do it. So first of all, let's just notice in this, instead of x or anything, it says dv. So it means that you have to do it with respect to v. So this basically just means that you're doing something to the v in order to find the derivative, right? You have to do something to v in order to find the derivative. So power law states when you add subtract terms, you can just find the derivative of individual terms. So I'm going to find the individual term derivatives, so like that. So let's find the derivative of 3v to the power of 5. So 5 times 3 is 15. V, 5 minus 1, which is 4. Right? Now let's look at 4v squared. So 4 times 2 is 8. 8. Leave v as it is, and then 2 minus 1 is just 1. Right? Now, remember again that you have to take in the signs as well. So I'll have to take in the negative sign as well. This negative, I'll have to take in. So always remember that. And if you notice, I take in signs for everything. This is plus, but it's just hidden, right? It's just hidden. I don't have to write it. But when it's negative, you do have to write it. So you have to find the derivative of negative 5 over v squared. Now here you have to be good with your index laws. Do you remember having, if you have 1 over v, it could be written as v to the negative 1. Similarly, if you have 1 over v squared, you can write it as v to the negative 2. Right? So I can rewrite this as negative 5 times v to the negative 2. Right? Now I can just use power law. Simple, right? Times this negative 5 times negative 2, which gives me positive 10, because negative and negative make positive, and 5 times 2 is 10, meaning positive 10. And then you have v, and then you minus 1 from the exponent. So negative 2 minus 1 is negative 3. So I write negative 3 here. And similarly, if you can write v to the negative 2 like 1 over v squared, you can write v to the negative 3 as 1 over v to the power of 3. Right? So this can be just 10 divided by v cubed. So now I have individual derivatives, right? So individual derivatives, here I have 15 v to the power of 4, 8v, and 10 divided by v cubed. So the answer to this question would not be this, or this, but would be this. Because when you combine it, it becomes 15v to the power of 4 plus 8v plus 10 over v cubed. Right? Simple. And that's it for today's lesson. So thank you for watching our video, and please subscribe and also like the video, as well as press the notification button, because we will be making new videos on calculus and all the other AISL course over the time. So thank you for this, and have a good day. Thank you.